There's an assumption baked into almost every AI infrastructure conversation, and it's so common nobody really questions it anymore. Better output costs more money. If you want the best result on a hard reasoning task, you call the most capable frontier model, you pay the premium per token, and that's just the cost of doing business. The budget models are for drafts, for low-stakes summarization, for the stuff where you can afford to be wrong. OpenRouter's Fusion is worth sitting with tonight because it pushes back on that assumption pretty directly, not as a marketing claim, but as a benchmark result. And if the result holds up under scrutiny, it's not just a pricing story, it's an architectural story about where the real intelligence in an AI system actually lives. So, let me walk through what Fusion actually is, because it's not a model in the traditional sense, and that distinction matters a lot for how you'd use it. OpenRouter already operates as a model routing gateway. You point your API calls at them, and they handle forwarding to whichever provider and model you've selected. Fusion is a layer on top of that. Instead of routing your request to one model, it decomposes the task, sends parts of it to multiple cheaper models simultaneously, and then aggregates the outputs into a single response. The engineering decisions underneath that are genuinely interesting. There's a task decomposition step that decides what gets split and how. There's a model selection heuristic that matches subtask characteristics to the models most likely to do well on them. A model that's strong on code generation might handle one chunk, while a model with better factual recall handles another. And then there's an output aggregation step that stitches the results together into something coherent. None of those steps are trivial. Each one is an opportunity to either add value or introduce error. The reason this is worth paying attention to now is that doing all three steps reliably enough to clear frontier model benchmarks is, honestly, harder than it sounds. The conventional wisdom was that the coordination overhead would eat the cost savings and introduce enough inconsistency to make the whole thing impractical for production. What Fusion's results suggest is that the coordination problem is more solved than most people assumed. Now, the claims that matter here are on the benchmarks, and this is where I want to be precise about what the source actually establishes. According to OpenRouter's own published results, Fusion outperforms single frontier models across a range of benchmarks at a fraction of the cost. The specific framing from OpenRouter is that budget model routing can beat frontier AI on the tasks they tested. The category of tasks where this shows up most clearly is reasoning and coding, which are, not coincidentally, the categories that practitioners care about most and that frontier models have historically justified their price premium on. The honest read here is that OpenRouter is presenting their own benchmark data, so you should weight that accordingly, and I'll come back to that. But even granting that caveat, the directional claim is meaningful. If you're routing a complex coding or reasoning task through Fusion, you're not just getting a cost reduction with some capability trade-off. According to these results, you may be getting a capability improvement. The cost angle is worth spelling out concretely. Budget models from providers on OpenRouter can run at an order of magnitude cheaper per million tokens than frontier model pricing. When you're running Fusion across multiple budget models in parallel, your total compute cost per task is still substantially below a single frontier model call. So even if the latency is somewhat higher, which it often is because you're doing more work, the cost per quality unit is dramatically better on the tasks where Fusion performs well. That's the practical upside. That's the thing that, if you're managing inference costs for a production system today, you probably want to test yourself. Okay, so let me give the strongest version of the case against this, because I think it's actually pretty strong and practitioners deserve to hear it. The first objection is latency, and it's real. Decomposing a task, dispatching it to multiple models, and aggregating the results takes time. For a lot of production use cases, especially anything user-facing with tight response windows, that latency budget doesn't exist. A single frontier model call may be slower than a cheat model call, but it's almost always faster than an orchestrated multi-model pipeline. The second objection is context coherence. When you split a complex task across multiple models, each model is operating on a fragment. They don't share a working context. They can't catch each other's errors mid-reasoning. The aggregation step has to do real work to make the output feel like one coherent thing, and that aggregation step can fail in subtle ways that are genuinely hard to debug. The third objection is what I'd call the orchestration tax. Every additional model in your inference pipeline is another failure point, another latency jitter, another rate limit to manage, another vendor to worry about. Running one frontier model call is easy to monitor and reason about. Running a Fusion-style pipeline requires more engineering discipline to operate reliably, And if you're a small team, that operational overhead has real costs that won't show up in your token bill. And honestly, there's a fourth thing worth naming. OpenRouter's benchmarks are OpenRouter's benchmarks. They're measuring performance on tasks they presumably selected because Fusion does well on them. That's not a disqualifying fact, but it's a reason to run your own evals before you restructure your inference stack. So where does this leave things, after sitting with both sides for a bit? I think the interesting frame here isn't Fusion versus frontier models. It's what Fusion signals about where value is accumulating in the AI stack. Think about what happened with CDNs and origin servers. At some point, the routing and caching layer, the infrastructure that decided where requests went and how responses were assembled, became more strategically important than any individual origin server. The origin server is a commodity. The routing layer is defensible. Something similar might be happening with AI inference. If the model is increasingly a commodity, and if the orchestration layer can reliably improve on what any single model does alone, then the engineering discipline that matters shifts. It's less about which model you pick, and more about how you route, how you evaluate, and how you aggregate. That's a genuinely different set of skills than what most teams have been building for the past 2 years. And OpenRouter, by owning the routing layer across many providers, is positioning itself in a structurally interesting spot, regardless of which underlying models win or lose the benchmark race next month. For practitioners, I think this is probably real, especially for high-volume, cost-sensitive workloads, where the tasks are decomposable and latency tolerance is moderate. The failure modes I described are real too, and they're not fully addressed by the benchmark results. But I'd stop assuming that throwing a larger, more expensive model at a problem is the default right answer. That assumption is worth questioning more carefully now than it was a year ago. Practically speaking, here's where I'd start. If you're running a high-volume pipeline on reasoning or coding tasks, and your latency budget is somewhere above a second or two, Fusion is worth an afternoon of testing against your actual workload. Not OpenRouter's benchmarks, yours. Your tasks, your eval criteria, your acceptable error rate. If latency is your binding constraint, or if your tasks require tight context threading across the full problem, I'd hold off on Fusion for now and keep watching how the aggregation quality improves. And the thing I'd watch most closely going forward isn't the benchmark leaderboard. It's who builds the routing layer that practitioners actually trust. That's the position in the stack that I think matters most over the next couple of years, and it's not settled yet. That's your evening context. See you tomorrow.